Hello students, today our topic is free radical substitution reaction and its mechanism. First of all, before talking about free radical substitution reaction and its mechanism, we should know how radicals are formed, or you can say how free radicals are formed. See, if there is a compound AB, two conditions can be there. In one case, electronegativity of A and B are not equal. If electronegativity of A and B is not equal, then obviously more electronegative element, either A or B, will attract shared pair of electron towards itself and get negatively charged and will be known as anion. And the species which is less electronegative obviously will be deficit of electron pair and will be positively charged and known as cation. So this is when the difference in electronegativity between A and B is there. But if the difference in electronegativity is not there, A and B both will be having almost same electronegativity, then equal distribution of this electron pair to A and B will be there, and free radicals A and B will be formed. This is an example of homolytic cleavage. If the electronegativity of both constituent elements is same, then equal distribution of electron from this bond pair will be there, shared pair will be there, and free radicals will be formed. And this is an example of homolytic cleavage or homolytic fission. Important conditions for this homolytic cleavage will be HELP, that is heat. It should not be less than 500 degrees centigrade temperature, that is electricity. Light, it must be ultraviolet light, then only this homolytic cleavage can take place. And the peroxide is O2 2 minus. So heat, it should not be less than 500 degrees centigrade. Electricity, light is ultraviolet light, and peroxide, that is O2 2 minus. So if we provide these four conditions, then only homolytic cleavage will be formed, then only free radicals can be formed. So in this way we can form free radical. So now the example of this free radical substitution reaction is halogenation reaction. Here we are talking about halogenation of alkane. In halogenation of alkane, hydrogen will be lost one by one from the hydrocarbon, from the alkane, and instead of that hydrogen, halogen will be added. Since in this halogenation of alkane, loss of hydrogen will be there, so it is called dehydrogenation reaction, that is an oxidation reaction. And since Cl or halogen is added in this reaction, that is why it is called halogenation or chlorination reaction, that is also oxidation reaction. So you can say free radical substitution reaction, that is halogenation of alkane, is an example of oxidation reaction also. In this halogenation of alkane, we will talk about the mechanism of the reaction. In this mechanism of reaction, first step is initiation, second is propagation, and third and final step is termination. In initiation reaction, there will be generation of free radical. That free radical here, we are taking Cl2 in this part of the reaction, we are taking Cl2 to generate free radical. Cl2 in presence of sunlight will form Cl free radical. In second step, that is propagation step, this free radical Cl combines with methane, marsh gas or fire damp to form CH3 free radical, methyl free radical, and HCl. In next step, since it's a multiple step reaction, this propagation is multi-step reaction part. So this CH3 free radical combines with Cl2 to form CH3Cl plus Cl free radical. This Cl free radical again combines back with CH3Cl to form CH2Cl free radical and HCl. This CH2Cl free radical combines with Cl2 to form CH2Cl2, that is dichloromethane, or methylidene chloride, that is geminal dichloride, to form Cl free radical. In this way, in propagation step, one by one all hydrogen atoms will be lost, and in place of hydrogen, halogen will be added. First we will get CH3Cl, then CH2Cl2, then CHCl3, that's chloroform or trichloromethane, and finally you will get CCl4, that is tetrachloromethane or carbon tetrachloride, or pyrene, that's a fire extinguisher, or perchloromethane. So we can say in this reaction, halogenation of methane, we will get mixture of CH3Cl, CH2Cl2, CHCl3 and CCl4. In third and final step, that is chain termination step, two free radicals combine together to form Cl2 and C2S6. ClCl free radical combines together to form Cl2, and CH3CH3 free radicals combine together to form C2H6. So in this way, halogenation of alkane can be done. So this is an example of free radical substitution reaction. Thank you very much.